Good morning, calculus type people. Hope you're having a fantastic day. Today is the day. It's all been leading up to this. The FTC, otherwise known as the Fundamental Theorem of Calculus. Now, you will need a calculator for this one. Just kind of get it ready to go, ready and raring. I'm going to use it for a couple of different illustrations here. Now, first, before we get into all this, just a few notes about what all this means, what the fundamental theorem of calculus is, what it does, excuse me, and what it means. So first, it tells us that differentiation and definite integrals are inverse operations, right? So differentiation and integration are doing inverse things. They're doing inverse operations. To approximate the slope of a tangent line, we do the change in y over change in x. Right? To approximate the area under a curve, we do the change in y times the change in x. So the area was length times width, or height, base times height. The approximate slope was delta y over delta x, y2 minus y1, x2 minus x1. It's the formula for slope, right? Well, these are the algebra ways of thinking about this. Now, in the calculus way, you have your derivative, which is, like, let's say we use a simple function x squared. Well, then f prime of x would be 2x, right? And then you know that the integral, if you're looking at the integral of 2x dx, then it's going to be x squared, right? And these are the kind of the calculus standpoints on it, the calculus way of doing things. So what we're going to do here to kind of figure out what the fundamental theorem says, we're going to use the velocity functions here. It says using velocity to investigate the fundamental theorem of calculus. So here they give us position. S usually denotes position, right? I'm going to write that up here. Position. Bam. And it's 2t squared plus 1. All right. And it says find the displacement on the interval 0 to 2. This is an algebra question. Displacement, very simply put, is from 0 to 2. So you're going to find s of 2, right? And subtract it from s of 0. Find s of 2, subtract it from s of 0. I just want to know, if I started at 0 and went to 2, how far did I go? So plug them into position and see if you can figure it out. 2 squared is 4 times 2 is 8 plus 1 is 9. Minus 0 plus 1 is 1. So you've gone 8 units. Between 0 and 2, you've gone 8 units. And you know that the derivative of position is velocity, right? So for this one, it would be 4t. And it wants us to find the area under the curve from 0 to 2. So if I was to graph 4t, it would go through the origin, up 4 over 1, up 4 over 1, 1, 2, 3, 4. Yep, got it. Down 4 over 1 as well. So what they're asking me to do here is just simply come up with the graph for 4t. So far, this is the only way we know how to do this. And come up with the area from 0 to 2. So here's 2. So they want me to come up with this area right here, right? From 0 to 2. So here's the way that I would look at this. I'd say the integral from 0 to 2 of 4t dt, right, is going to be equal to 1/2, because it's a triangle, so 1/2 base times height, 1/2 base of 2, and a height of 8. And that's from plugging 2 in right here, which is 8. Notice any similarities between these two questions? What they're saying, if velocity is the derivative of position, then position is the antiderivative of velocity, right? Let me write that down like this. S of t is going to be the integral of v of t, right? And that kind of makes sense. That follows one after the other. The derivative of velocity is, or the derivative of position is velocity, so the integral of velocity is position. Evaluated from 0 to 2. Evaluated from 0 to 2. See, what they're saying here is that the integral from 0 to 2 of 4t dt is the same thing as s of 2 minus s of 0. This is the same as this. And so here's how we build up to that. Excuse me, I don't need that equal sign there. Here's how we build up to what we call the fundamental theorem of calculus. The integral from a to b, this is a, this is b, a, b, of little f of x, lowercase f of x, dx, is going to be capital F of b minus capital F of a. What you are doing is figuring out the integral, plugging in b into the integral, plugging in a into the integral. And it's that simple. Now let's go over a couple of examples here, or not a couple of examples yet, but just the actual theorem itself. The fundamental theorem of calculus says that the integral from a to b of f of x dx is equal to f of b minus f of a, capital F, where x is continuous and differentiable. Very important there, continuous and differentiable. All right, and f prime has to be little f. Big F prime has to be little f. Right? So I'm going to try and go through this as quickly as I can here. There are quite a few notes, but let's jump into them here. Observations. It says provided you can find an antiderivative of f, you now have a way to evaluate a definite integral without having to use the limit of a sum. No more sums. No more sums. At least until the AP test. Then they're going to drag that thing back out of you again. And here's the notation. These two you've already seen, right? The integral from a to b is f of b minus f of a, cap f b minus cap f a. Cap f a. Sounds like a coffee drink. Here's the notation on that. You're coming up with the integral, capital F of x, and you're evaluating from a to b. But remember, larger number always goes first, right? Larger number first, smaller number second. And just a couple of properties really quickly. If you're integrating from a to a, that's kind of like having a rectangle with no width. If you have no width, your area is going to be 0. So that just kind of follows and makes sense. If you're going from a to b and your integral is switched, if b is on bottom, the larger number always has to go on top. And you'll see an example of where we'll do this in a little while, in a few days. But if it's from a to b, if b is on bottom, you have to switch it and just make the integral negative. All right? Switch it and make the integral negative. It's kind of like just finding the opposite. All right? So bigger number always goes on top. And then finally here, the integral from a to b. This is what happens if you have to integrate to some letter in between. Like if you have a negative integral and a positive integral, or if you have two numbers in between each other, like a and b and c's in between them, then you can do the integral of a to c and then c to b and kind of bridge those two pieces. So if you have to go from a to b, right? A to b with c in the middle, then you can do a to c and c to b. And it comes up with the same thing. It's just saying you can break up those two integrals. So your first example here, it says integrate from 1 to 2 x squared minus 3. Now this is the awesome thing about integrals, definite integrals. There is no plus c. On a definite integral, there is no plus c. Because I'm not worried about that arbitrary constant. I just want the area under the curve. That's what the definite integral gives me. So I don't have to worry about an arbitrary constant. So let's do this. The integral here, remember that this means it's going to be evaluated from 1 to 2. And let's find the integral, x squared. So that'll be x cubed over 3 minus 3x. And I don't need a plus c because all I'm doing is finding area. It's amazing. So evaluate that from 1 to 2. So first I'm going to take this whole thing and evaluate it at 2. Remember, the big number comes first. So this whole thing, 2 cubed over 3 minus 3 times 2. And I'm going to subtract. Remember, it's f of b minus f of a. So here's f of b. Now I'm going to plug in a into this equation. So my a value is 1. 1 cubed over 3 minus 3 times 1. All right, and that's going to be, what is that, 8 over 3 minus 6. Now this minus sign will have to go both places. That's probably one of the things most people miss, is that minus sign. This is 1/3, so minus 1/3, and this will make this a plus now, 3. Oh man, which is putting everything into thirds here. Let's see, this will be minus 3, call that 9/3. 8/3 minus 9/3 is negative 1/3, minus 1/3 is negative 2/3. If that just confused you, pause the video and work it out. So check this out here. My area is negative. Yay! Think about what that looks like for just a moment here. X squared minus 3 is a parabola shifted down 3 units. Right? So up 1 over 1, so here's 1, it'll go like this, and 2, it's above. So most of your area is negative. Now, grab your calculators real quick. Grab your calculators. And here's what we're going to type in. Oops. You know what, let me just show you real quick. Go to your home screen. And if you press math number 9, fn that's function integration. Yay! Oh look, it's pretty print. If not, I'll show you what it looks like here in a second. And just plug in the integral. You've got 1, go up to 2. Your equation is x cubed minus 3x dx negative 0.75. Math enter. Negative 3. Whoa, did I type that in right? Oh, crud. No, I didn't. I'm sorry. I typed in my... I typed in this. What was I doing? Good Lord. Math 9. From 1 to 2. I don't know what I was doing. I'm supposed to be typing in this. X squared minus 3. That's what I wanted. Dx. Now, much better. 2/3. Negative 2/3. It's magic. Alright. Now, for those of you who don't have the pretty print, is what we call it, here's what yours is going to look like. You're going to go to Math 9, and it says fn int. Fn, goodness, I can't write. Int. And what you're going to do here is type in your equation just like normal. X squared minus 3. And then you have to type in what variable you're using. So I'm integrating with respect to x. And then comma, I'm going to go from 1, comma, to 2. So it's the variable I'm integrating with. So with respect to x, that's like your dx. from 1 to 2. And I'm going to write this down for you real quick. X squared minus 3 using x 1 to 2. So yeah, you can use your calculator for this. All right. Let's keep going. Couple things here. The integral from 1 to 4 of 3 square root of x. One of your properties for integral says that if you have a constant or a coefficient out here, that you can actually bring that out front, and that is okay to do. So the first thing I'm going to do is bring out that 3. So here's what I've got. 3 integral from 1 to 4. And you know what? Let's go ahead and change that x, square root of x to x to the 1/2. Save me some time. Alright, so this is going to be 3 times, and let's integrate. This will be x to the 3/2. Over, now when I do the over 3/2 here, you know that's going to pop the 2 up, right? So let's just say 2x with a 3 on the bottom. Save space and time to the 4th. Or excuse me, evaluated from 1 to 4. Right? That's evaluated from 1 to 4. So I'm going to do the evaluation first and then multiply my 3 through at the end. So let's see what this is going to look like. We've got 3. Let's evaluate. So if I put a 1 in here, this is going to be, or excuse me, if I put a 4 in here rather, 4, the square root of 4 is 2, cubed is 8, times 2 is 16 over 3. Again, I did the square root first and then raised it to the power of 3. Right? Minus f of b, so put in your, or f of a, put in your 1, and it's 2/3. Which is 3 times 14 over 3, which is 14. And notice that gave me a positive area. I'd like you to check that with your calculator and make sure that your area is positive. What you actually get with this is a square root function from 1 to 4. So you should end up with a positive area. 1 to 4. Alright, example number 3. Alright, this one's a special one because it's an absolute value. And anytime you have an absolute value, you must split it. So I want you to write this down. Always break the absolute value let's do this. Always break where the absolute value is equal to 0. Always break where the absolute value is equal to 0. So I'm going to go to the inside of my absolute value here, 2x minus 1. Set it to 0, and you get 1/2. So what that means here, just kind of visually, what you're looking at, here is 1/2, and it goes like this. So you're finding the area from 0 to 2. Okay, you see how we're going to have to break this thing up? You always break the absolute value at the place where the absolute value is 0. So what I'm going to do is I'm going to break this up. This is my C value. So what I'm going to do here is say that this is the same thing as the integral from 0 to 1/2. And this is the negative portion of my square root. So it's negative 2x minus 1 dx plus the area from 1/2 to 2. This is going to finish it out. Of the positive side of 2x minus 1 dx. Remember, if we break this thing up, kind of like if we were rewriting it as a piecewise function, we'd start out with the negative side and then the positive side, left to right, that kind of thing. And then we can just integrate. So this is going to be, pull your negative 1 out of here, so it's negative times, and let's integrate it. This will be x squared over 2, so 2x squared over 2 is x squared minus x. Remember, I don't have to do a plus c here. Hallelujah. From 0 to 1/2 plus, let's do this one here. The 2x minus 1, same thing, so x squared, let's do box x squared minus x from 1/2 to 2. So I'm breaking this thing up, right? Okay. Now at this point, you have to bust into your f of b minus f of a and go about all that jazz. F of b, so I need the 1/2. This is going to be negative. If you plug a 1/2 in here, you get, let's see, that'll be 1/4 minus 1/2 f of b minus f of a, which is 0, plus f of b, which is 4 minus 2, minus f of a, which is 1/4 minus 1/2, right? F of b minus f of a, f of b minus f of a. Let's figure out what this thing's going to be. So we have 1/4 minus 1/2. Actually, you know what? We can do it. Well, no, let's do it. And everything. If you notice, everything is in eighths here. Let's simplify this all kind of togetherness, right? Let's see. It'll be negative 1/4 plus 1/2 plus this will be 2 minus 1/4 plus 1/2. Right? No, something about that's not working out. For the sake of time, I'm going to grab a calculator here. What is that? I don't want to do eighths. Oh, eighths are annoying. Whatever. This will be 2/8 minus 1/8 be 1/8, so it's a negative 1/8. And then plus 2 minus 1/8. That seems right. 2/8 minus, no, 1/2. Never do math this early in the morning. Oh, I can't think for some reason. 1/2. That's 1/4. There we go. So that's positive 1/4. That's what I'm looking for. And then plus another 1/4. Mercy sakes, 2.5. Or if you're really feeling adventurous, what would that be? 5/2? Right? And then of course you can check it on your calculator. Trying to get through this very quickly. I apologize, this is a long one, but it's an important day, it's a fun day. The integral from pi over 4 to pi over 2, 2 minus cosecant squared x. So first, let's figure out what the integral is. This will be 2x for this guy, minus the integral of cosecant squared is cotangent x. And that's evaluated from pi over 4 to pi over 2. Which is going to be, let's do pi over 4, or excuse me, pi over 2 first. F of b always goes first. So this is going to be 2 times pi over 2 I'm going to show my work on this one. I seem to be getting confused early this morning. Cotangent of pi over 2. That's f of b minus f of a. 2 times pi over 4 minus cotangent pi over 4. Right? Which is going to be, let's see, this will be 2 times pi over 2 is pi. The cotangent at pi over 2, if you remember, this guy would be x over y, which is square root of 2 over 2 over square root of 2 over 2, which is 1. Right? No, that's pi over 4. Oh, goodness. Pi over 2 is up here. X over y is 0 there. Remember to distribute your negative sign here and here. All right, so we have minus, let's see, we got 2 times pi over 4 is pi over 2. And the cotangent of pi over 4, I can't believe I did this again. I forgot that this is positive. Some of you probably caught that right off the bat. I forgot this is supposed to be positive. No worries, easy fix. Easy fix. Minus cotangent of pi over 4. Never do calculus this early in the morning. Here is where it's the square root of 2 over 2 over the square root of 2 over 2. Perfect example though. You know, I've been doing this for years and I still get tripped up on this stuff. But it's okay. You work through it. When you see something's wrong, stop, fix it, work through it. So this is 1, which is pi minus a half of pi is a half of pi minus 1. And I don't want to use an approximation for this, so I'm going to leave it just like that. I do not want to do an approximation. All right. So very, very quickly, and again, I apologize about the time, but let's get this done. 3 minutes, I can do this. All right, finding the displacement or total distance traveled using position equation, the displacement of an object from a starting position to an ending position. Total distance traveled is calculating the distance between turns and then adding it. Remember, displacement, you can just add up from the starting to the ending position. So if I start at home, travel to Dallas, come back home, my displacement is 0 because I started where I ended. But the total distance traveled, I have to calculate the distance from here to Dallas, then I turned around and calculate the distance from Dallas to here, right? Or the other way of doing that, another way to find the displacement or total distance traveled using velocity, displacement is the integral from A to B. Total distance is the integral from A to B of the absolute value of V of t. And the absolute value, I'm going to flip back real quick, we'll have to handle like example number 3. So we'll just split it when it turned, right? Same way we did the absolute value down here. Split it when it turns. So very quickly then, it says a particle moving along the x-axis so that its velocity at time t is given by this equation. Find the total distance from 0 to 2. Find the displacement of the particle from 0 to 2. All right, and I'm actually going to use my calculatore for this. It's going to be a lot easier that way. It's going to be the integral of 0 to 2. First, total distance. Now, distance is the absolute value one, right? Distance is the absolute value of t cubed plus 3t squared minus 4t minus 3 dt. And I can actually come over here and I can plug that straight into my calculator. Math 9, x cubed plus 3x squared minus 4x minus 3. If we got that good, comma x. Oh, and I forgot the absolute value. So I can insert catalog absolute value. Comma x, comma 0, comma 2. thinking 6.831. And that'll just be units squared, right? We're talking about velocity. We don't know what it is, but it's units squared. So then total displacement then, the integral from 0 to 2 of just t cubed plus 3t squared minus 4t minus 3 is the same thing, second enter, but I'm just going to go back and take out my absolute value. -2. So you can see a pretty big difference as far as the number or the actual amount of area covered when you're talking about distance versus displacement. And I just barely made it. All right, have a good one, guys.